Okay, section 4.2, logarithms. Log base a of x means the following. A to what power is equal to x? Really, the idea that we want to get to is the following. Think about that problem. 3 to the x power is equal to 42. What power would you take 3 to in order to get 42? What's 3 squared? 9. What's 3 to the third power? 27. What's 3 to the fourth power? 81. So you can see that x value is going to be, say, 3.5 or something like that. It's going to be between 3 and 4. So logarithms help us solve for exponents. Logs help us solve for exponents. And what you have to be able to do is you have to be able to translate between the two. So log base a of x means a to some power is equal to x. And we'll rewrite things in exponential form and in logarithmic form. So a lot of this stuff is just by definition. Now, this is really important. You see this a right here, that's the base. And so this means a to some power is equal to a to the x. Well, you tell me, what power would you take a to in order to get a to the x? X. Now pause. Just don't write anything, just watch this. If I want to solve that equation, what do I do to both sides? 3/5, right? Because the inverse operation is to multiply by the reciprocal. If you want to solve this equation, you add 7, because adding the opposite is the inverse operation. If you want to solve for this, you can take the function value of both sides and you will get x. Notice that these undo each other, right? Notice that the plus 7 and the minus 7, those undo each other, right? And the f and the f inverse undo each other. That is also true with logarithms. Hey, where am I? Here we go. If you look, log base a of a to the x, what happens is those go away and leaves you with just x. Similarly here, a to the log base a, this is a base taken to an exponent, and as you have log base a, those go away, you're left with just x. Now I know that looks confusing, but trust me, we'll be able to solve it later on. Because later on I'm going to be giving you guys equations, and it's going to look something like this. And I said try to solve that, right? Well, here's how you solve it. If I take the log base 3 of both sides, what happens to these? And you're left with x is equal to the log base 3 of 42. So, what power did you take 3 to in order to get 42? Well, the log base 3 of 42. We can figure that on our calculator very easy. So, you're not going to do that right now, but in order to do problems like that, or even more confusing ones, like 2 to the 3x equals 3 to the 4x minus 5. If we want to solve those type of equations, we have to be very good with the properties of logarithms. That's where we're getting. Let's try some of the easier problems right away. It says as follows, express the following in exponential form. So if you see log base 2 of 32 equals 5, this is the base and this is the exponent. So that means 2 to the 5th power is equal to 32. Would you agree that that's true? Can somebody give me the exponential form of the next one? What's the base? 6 to the 2nd equals, good. How about C? 12 to the 0 equals 1. For D, change it to 5 on the end. Sorry about that. I write these from scratch and sometimes I make a mistake. What should I do here? 3 to the 5th is 243. Ooh, natural log. What's different about natural log? What is the base of a natural logarithm? No. Base of a natural log is e. So I could rewrite like that. Log base e of e is equal to 1. Write that in exponential form. E to the 1 is equal to e. Natural log of 1, I could rewrite as log base e of 1 is equal to 0. So that means e to the 0 equal to 1. So, can you write logarithms in exponential form? Good. Now, let's try to write exponential equations in logarithmic form. 2 to the 4th equals 16. I can write log, what's the base? 2 of 16 is equal to the exponent. Again, they solve for exponents. So it's the exponent that goes over here. Log base 2 of 16 is equal to 4. The next one, log base 10 of 100,000 is equal to 5. Now here's something that you have to know. When you see natural log, you don't write base e. Okay, it's just assumed. And when you see log base 10, you don't have to write the base 10. It's just assumed. So we could just write log of 100,000 is equal to 5. Just to show you what I mean. Hi, Greta. What? We want to make sure we see her, right? See, when I put in log, I don't tell what the base is. I just put in log of 100,000. So it's assuming that the base is 10. And if I do that, I do get 5. Okay? All right, let's finish these off. 8 to the negative 2 equals 1/64. What does that look like? Log base 8 of 1/64 is equal to negative 2. Good. How about the next one? Log base 7 of 1 equals 0. Next one, log. I don't have to write the base because the base is 10 of 1/10 is equal to negative 1. And for f, instead of writing log, I would write ln, natural log, of e is equal to 1. Any questions there? You may wonder why we use logarithms. I'm going to tell you right now that in calculus, logarithms are extremely, extremely useful. And they're extremely useful actually in money. Growth of money, compounding interest, all sorts of stuff. Also growth of bacteria, decay of elements, all sorts of interesting pieces. Okay, flip it over. What? You don't like the red dot? Oh. What is the log base 4 of 64? What? That means 4 to what power is equal to 64? 3. 3 to what power is 1/9? -2. 8 to what power is 8? 1. 5 to what power is 5 to the x plus y? X plus y. Now, everybody pause, because I want you to see what's happening here. Log base 8 of 8 to the 1. What happens to the log base 8 and the base of 8? Those cancel. Leaves you with just 1. Look at this. Log base 5 and the 5. Those cancel. Leaves you with x plus y. 3 to the log base 3. Those cancel. Leaves you with just 7. So anytime you see those inverse operations on one another, you can just take the exponent. Natural log of 1 over e squared. You don't know how to do it? Write it out. That's the log base e of 1 over e squared. Or log base e of e to the -2. So e to what power is e to the -2? -2. Any questions? Okay, let's actually do some basic equation solving. Log base 2 of x is equal to 3. We need to figure out what x is. So let's rewrite 8. Very good. Let's rewrite it in exponential form. The base is 2. This is 3 is equal to x. So x is going to be 8. Thank you, Miss Bailey Barber. If the base is x and the exponent is 2 equals 100. X squared equals 100. What is x? 10. 5 to the x power is 125. What do you have? X is 3. Cross out 49. Let's make it 11. Doesn't really work very well. That'll be x to the 1/2 power is equal to 11. What number do you take to the 1/2 power to get 11? What number do you take the square root of in order to get 11? 121. Did you say 122? Well, that's just silly. Give me a 2-digit number. Yep. Give me a 2-digit number. All right. You know how to multiply by 11s? Put the 1, put the 2, add them together. 3. Give me another 2-digit number. All right. 49 times 11. Put the 4, put the 9, add them together. 13. So 3 carry the 1, 539. Give me another one. 77. Ooh, look at this. 7. 7. What's 7 plus 7? 14. Drop the 4, carry the 1. 847. No, it works with 3 digits as well. Give me a 3-digit. 367. Watch this. Times 11. We'll go 3, 6, and 7. What's 6 plus 7? 13, carry the 1. So that's 7 now, right? 3 plus 7? 10, carry the 1. So that'll be 4. So 4, 7, 3, 7. Actually, I have no idea if that works. I just made it up. And this, right? Oh, okay, all right. I just made that up, so I don't really know. Okay. All right. No. It works for the 2 digits. There is a pattern for 3 digits. I don't know for sure what it is. So. Whoa. Wait a minute. So are you telling me that what you wanted was, instead of learning how to do multiplication, okay, then you wanted to learn all the tricks. Okay, then you want to learn all the tricks. Hannah, maybe the reason why, maybe your teacher didn't know. I bet your teachers were awesome. I know. Okay, let's continue on. Log base 2 of 0 equals x. So that's 2 to what power? 2 to the x power is equal to 0. How do you know that? Bailey is right. Bailey is on a roll today. You're right. X is undefined. You cannot take a number to a power and get 0. It's just impossible. Now, you guys got to put your pencils down because you got to watch this part. Come on in. We're at the exciting part of the lesson. So, do you guys remember when we graphed exponential equations the other day? Like y equals 2 to the x? Remember when we did that? Here's the deal. That's exponential. Its inverse means reflected over the line, y equals x. Its inverse is going to be y equals log base 2 of x. So exponential functions and logarithmics are inverses of each other. They flip over the axis. Now think about it. Look at this graph. Can I plug in positive numbers and get out results? Yes. For the blue graph, can I plug in negative numbers and get out results? No. Can I plug in 0 and get out a result? No. So you can see that the domain for logarithms does not include negatives or the number 0. You can only plug in positives. And so if you end up with this situation where it says the log of 0, it's undefined. If you got the log of -9, or the log of 0, or the log of -pi, all of those are undefined. They're not in the domains. It would have to be, say, log of 6.4. That works out because it's positive. And we will take more time, if we have time at the end of this unit, to examine the domain and the range and the relationships of these graphs. But that's how you think through this. So think of this graph, flip it over the line y equals x. This is your new graph. There you go. Okay, let's finish this off. Log base 10 of x is equal to -3. That means 10 to the -3rd power is equal to x. So what would x be? One over 1,000. Okay. Last examples, and then you guys will have your assignment. Find a function of the form y equals log base a of x. The other day we did y equals a to the x. We did exponentials. Now we want to do logarithmic ones. given the function passes through the following points. Now, do you remember from the other day that all of these pass through what point? What point was this right here? 0, 1. Good. So all of the logarithmic ones are going to pass through this point, which is 1, 0. Just that reflected across the line y equals x. So we know that that's true. It passes through 1, 0. We have to see about the other piece. So let's see if we can figure these out. As you can see here, they pass through 1, 0. Passes through 25, 2. So my y value is 2. And my x value is 25. So what number do I take to the second power to get 25? 5. So that's our function. So a is equal to 5, so I can write my function as y equals log base 5 of x. This one, my y value is negative 1. Okay, what number do you take to the negative 1 power to get 1/6? What number do you take to the negative 1 power to get, yeah, good, 6. We are writing an equation for a function that passes through the points. This one, I have 4 is my y value equals log base a of 10,000. What number do you take to the 4th power to get 10,000? 10. So I can just write y equals log of x. I don't even have to write the 10 because 10 is assumed. And the last one, 1 is equal to log base a of 7. What number do you take to the first power to get 7? 7. Got it? Today is practicing properties of logarithms, basic properties. Tomorrow we will be working with multiplication, subtraction, addition, division. Be a little bit more involved. Friday will be harder. Good thing is you guys had this all last year, right? Difference is instead of taking a month on it, we're going to take about a week and a half. Okay? And you guys will have 4 college credits all wrapped up. Did I tell you how many credits I went into college with? 0. No. Your credits are being paid for by taxpayers and the state. Now, I know it looks like a lot, but we just did, I think, about 48 problems in class right now, okay? So we did a ton of problems right now, or 30, somewhere around there. We did a ton of problems right away. So you actually have 1 through 33 odd. That's going to be 17 problems. And then 35 through 44, that's another 10, so that's 27 problems. So you can get through this. Stay on top of your homework. And come to class prepared tomorrow. We're moving on to the next section. Good luck.